All right, so we're continuing our discussion with logarithms, but we're turning a page with this video. So up until now, everything we've been doing is kind of an introduction to logarithm. What is it? How does it connect to exponentials? How do the graphs look? How do these types of functions behave? Those sorts of things. Now what we're going to be doing is we're going to be getting into some uses of the logarithm. So with this video, we're going to introduce the first use that we're going to talk about in our class, and that's using it to solve an exponential equation. So this video is going to be working with only very basic equations. We're just going to introduce the idea of solving equations in this video. Our next video will go into some more involved equations, some equations that are a little bit more complicated. And then we'll be moving on after that to other applications with logarithms. All right. So with all of that said, let's go ahead and get started by taking a look at the learning objectives for this video. So 3 learning objectives here, and you can see the first 2 are basically the same learning objective in reverse. We're going to use logarithms to solve exponential equations, and we're going to use exponentials to solve logarithm equations. So that should make sense to us because the logarithm and the exponential are inverses. And we know from our previous use of inverses in algebra class that you use them to solve equations. And so that's the first thing we're going to do. As a side note, I'm also finally going to show you how to be able to work with logarithms on a calculator, no matter what the base is. So we've run into problems in the past, like when we're working on graphs and things, because the most calculators only have log base 10 or log base e, the common log and the natural log, and that's all they have. So what happens if you have log base 3 or log base 5 or whatever? So we're going to finally figure out how to do that with a calculator in this video. All right, so with all that said, let's get started. And as I typically do when we're working with inverses and things at this higher level, like we are in Algebra 2 class, I want to start by looking at inverses as we've learned them before, as we used them back in middle school. So this is just a quick reminder from back in the day, of ways that we worked with inverses. So for example, if you had a problem like 3 times x equals 9, and you had to solve that equation for x, back in the day, you would have said, hey, I'm going to divide both sides by 3. And that's exactly the right thing to do, divide both sides by 3. I have to do it to both sides because algebra says anything I do to one side, I have to do it to the other side also. And the reason I choose to divide by 3 is because up here, this means I have 3 times x. And the thing that cancels out multiplying by 3 is dividing by 3. So that's the reason we did this back in the day, is because multiplying and dividing cancel. And so that leaves me then with just the x on this side. And over here, I get 9 divided by 3, which equals 3. And so now I've got my answer. Okay. But by the same token, we also looked at problems where I said, OK, let's suppose I have x divided by 3 equal to 9, and I want to solve that equation. Okay, so this is a new equation. This is a new problem. These are not the same problem, right? This is problem number 1. This is problem number 2. Okay, 2 different problems, but they both have the same directions of solve. Okay, so here I was multiplying, and I chose to divide because dividing cancels multiplying. But now on this problem, I'm dividing. And so one of the things that you might have learned to do back in middle school or whenever it was you took pre-algebra is multiply both sides by 3. Why do I choose multiplying? For the same reason I chose dividing up here. Multiplying and dividing cancel each other. So if I start with a multiply, I can use divide to cancel it out. If I start with a divide, I can use a multiply and they will cancel out. And I'm left with just the x by itself. When the 3's cancel, what's left is just the x. And then on the other side, I've got some number, 9 times 3, whatever that is. And there's my answer. Okay, so this we already know. So from back in the day, from problems like this, we know that inverses can be used both ways. Here I'm using a divide to cancel a multiply. Here I'm using a multiply to cancel a divide, okay? It goes both ways. And so that's why in this video, what we're going to be doing is looking at both logarithms to solve exponentials and exponentials to solve logarithms, because inverses can go both ways. All right, so with that said, that quick review, let's actually get into a problem like like we're going to really do for this. Okay, so here's our real example number one. It's going to be to solve for x, and we're going to start with an exponential equation. Okay, so let's suppose I have, let's start with one that we can do. Let's say I've got 10 raised to the x equals this, 10,000. 10 raised to the x equals 10,000. Okay, so this is the problem that I need to solve. 10 raised to the x equals 10,000. All right, there are two different ways to think of this, and they are both completely valid. And every year I have some students who choose method number one, and I have other students who prefer method number two. And it's 100% up to you which way you prefer it. Method number one is to rewrite as a logarithm equation. Okay, so that we did in earlier videos about a week or so ago. We talked about anything that is in an exponential form, you can switch it to a logarithm form by following a certain pattern. So the way the pattern works is instead of an exponential expression, you're going to have a log expression. The base of the exponential becomes the base of your log. But then what happens is the thing that was in the exponential, that becomes your answer. And the thing that was the answer, that goes into the logarithm. Oops, I need one more zero. Okay, and so that is, so notice when I take this equation where x is inside of the exponential, if I rewrite it as a logarithm, now the x is by itself. Well, hey, as long as I can figure out what this equals, I'm done. And the nice thing is any scientific calculator or graphing calculator, including the scientific calculator that's built into most computers, is going to have log base 10, because log base 10, remember, is the common log, the one where we don't normally, whoops, push the wrong button, where we don't normally write the base, right? This is the same thing as just log with no base, right? So that's the same equation. That's an LOG. Okay, that's the same equation. If you write the base or if you don't write the base, it means the same thing. So now I can just type that in my calculator. Log of 1 with 4 zeros after it equals 4. So that tells me that this stuff, according to my calculator, is equal to 4. And so there's my solution to the problem, x equals 4. So that's one method based on what we learned to do in a previous video with taking an exponential function and rewriting it as a logarithm. Once I write it as a logarithm, that gets the x all by itself. And now I just type this into my calculator to get my final answer. So that's method number one. Okay. Method number two is more like this multiply divide example that we just looked at, like we learned back in middle school. And it's to use the concept of an inverse to cancel. Okay, so instead of rewriting as a log equation, we're going to use inverses to cancel. And again, you can do this either way, whichever way you want, it doesn't matter. They both work. They're both completely fine. So here, I start with my equation that's exponential. And then I know, because we remember we learned how to simplify expressions that have logs and exponentials both in them. When we did that in a previous video, we said, hey, as long as this base and this base match, as long as these two things match, then these will cancel and I'll be left with just the x or whatever's in the exponent. So I'm just taking the log of both of this side to get x. But remember, algebra says anything that you do to one side, you have to do that to the other side also. Okay, and remember, since it's base 10, I don't have to write the base. I can just write LOG. And since I don't really have room to write the base, I'm just going to leave it as LOG. And so notice if I use this canceling method, on this side, I end up with just x. Here I've got the log of 10,000. And so now I can type that into my calculator. And just like before, the log of 10,000 ends up being 4. And so notice both methods, so I do this on my calculator, both methods give me the same result. Both methods are the exact same amount of work. It really is just two different ways to think of it. One, you're thinking of it as, I know I can rewrite this as a logarithm. And when I do that, the x happens to be by itself. And so that's useful. The other method is I know I've got x in an exponent, and logarithms cancel exponents. So that will give me the x by itself. I just have to remember anything I do to one side, I have to do it to the other side also. So you can do these types of problems either way. All right, so what I'm going to ask you to do right now is to solve this problem. So I'm going to ask you to please pause the video and take a minute to solve e to the x equals 5. You can use either of these two methods that you want. It doesn't matter which method, but pause the video now and give that a try. All right, so hopefully you have solved this and come up with an answer. The answer should end up being a decimal. So if you got a decimal, that's okay. I'm going to go a little bit faster than I did on the last example, but I am going to still use both methods. So if you're somebody who tried to do this with method number 2, you might want to fast forward the video right now and skip the part where I do method number 1. All right. So for those of you who did method number 1, what you should have done is taken this and rewritten it as a logarithm. So I know the exponential, instead of an exponential, I'm going to have a log. The base is going to stay the same, so it's going to be base e. But what changes is the thing that was the answer is now inside of the logarithm, and the thing that was inside the exponential is now the answer. Now, log base e, I know that's the same as the natural log, and that is a button that's on my calculator. So now I can grab my calculator, I can choose the ln button, type in ln of 5, and now I've got my answer. It's approximately 1.6, depending on how you choose to round it off. And so that is my answer if I choose method number 1. Now, if you did it with method number 1, you should fast forward the video right now while I talk about method number 2. All right. So if you did method number 2, hopefully you've stopped the fast forward and you're ready to talk about method number 2. With method number 2, we use inverses. So I start with this equation. And I know, because this is in the exponential, that if I take the log of this, that'll cancel out. But it has to be the log that has the same base. So if this is base e, it has to be base e. Only log of base e will cancel an exponential with base e. They have to match bases. And if I do it to one side, I have to do it to the other side, right? So these things cancel, the log base e and the exponent base e, they cancel, and I'm left with just the exponent and nothing else. On the other side, I have this log, and log base e, we know, is the same as natural log, the ln. And there's a button for ln on my calculator. So now I can just find that button. I can type in ln of 5, push enter, and I get the answer. And the answer happens to be about 1.6. And so there's my answer. All right, so that's both methods of doing the problem. Notice both methods gave me the same answer. It's just two different ways to think of it. All right, so that is using a logarithm to solve an exponential. Now we're going to go about the reverse process. So for example number 3, what we're going to do is we're going to have a logarithm equation. And we're going to solve that. And again, we can do this using both methods. And it's the exact same method. Method number 1 is going to be to rewrite as an exponential. And that'll be our first method. Method number 2 is going to be to use inverses. And in this case, it's the exponential that is our inverse. So we can do it either way. I would recommend do it the same way for both. So if you used method number 1 to solve the exponential equation, probably want to use method number 1 to solve the logarithm equation. If you use method number 2 for the exponential, then you probably want to use method number 2 for the logarithm also. Okay, so I'll run through both of them again real quick so you can see this, and then we'll move on to our final learning objective and we'll wrap up the video. So in this particular problem, I have to recognize that this means base 10, right? That when I don't write the base, I have to recognize that this means base 10, all right? Now, if I rewrite this as an equation that has exponentials, I know instead of having a log base 10, I'm going to have an exponential with a base 10. But what's going to change is the thing that was the answer, that's going to become my exponent. And the thing that was in the logarithm, that's going to become my answer. And so notice when I do this, I do end up with the x all by itself equal to something. And now I can just type that in my calculator. 10 raised to the 5th power is, and there's my answer. It's 10,000, which I probably should have known because we just solved that a minute ago in example number 1. But that's okay. All right, so that would be method number 1. Now, method number 2, same idea. I have to recognize that the base is a 10. I have to recognize that. And now this is going to look a little funky when I write this, but the way that I write this is I'm just going to take the whole side. And remember, anything you do to one side, you have to do it to the other side. So I'm going to take the whole side and I'm going to make that into an exponent where the base is a 10 because my bases have to match. Okay, so that's called exponentiating the side. So I'm going to take both sides and I'm going to make the side an exponent where the base is a 10. Now, a lot of people look at that and they're like, whoa, that's really funky. Is that allowed? That's the beautiful thing, right? Remember, algebra says you can do anything you want as long as you do it to both sides. So if I want to do something funky, like turn this into an exponent, that's perfectly legal as long as I do it to both sides. Now, on the left-hand side, exponents and logarithms cancel. So those cancel each other out. And I'm just left with the x all by itself. Then I've got the equal sign. And on the other side, I have 10 to the 5th power. So now I just grab my calculator. I type in 10 to the 5th power to the 5th, and I get that answer. And it's, of course, the exact same answer that I had before. All right. So that is the basic process. I think I didn't get enough zeros. 1, 2, 3, 4, 5. There we go. 5 zeros. Did I have 5 zeros here? Oh, I missed a 0 over here too. Okay, 5 zeros. There we go. So that is our basic process of solving a logarithm equation. Again, just like the exponential, you can use either method, whichever way it makes more sense to you. And in the homework associated with this video, the equations that we're solving are what I consider simple equations. They're equations that just simply have a log of x or some number raised to the x, but there's not extra stuff. There's not like a +5 or anything like that that we have to worry about. All right, so that takes care of our first 2 learning objectives. Our last learning objective was to be able to solve anything on our calculator. So to do this, we're going to use something that is known as the change of base rule. Okay, and we're going to use a simplistic change of base rule. It's actually a little bit more powerful and a little more complicated than what I'm going to show you in this video. But I'm going to show you a simplified version of the change of base rule that's good enough to do what we need to do. So here's the change of base rule as we're going to learn it. So if I have a logarithm with any base, I'm going to put base A for any, okay? And then I've got some number inside. Let's just say x. Again, because I don't know what the number is, it doesn't matter what the number is, okay? This is going to be exactly equal to my common log, right? So log base 10, just normal regular log of whatever is on the inside. So that's x. And then that answer divided by the common log of the old base. So those 2 things are exactly equal. So what does that mean? That means if I want to figure out, like, what is log base 5 of 125? If I want to figure out that answer, then I can grab a calculator and I can type into the calculator the common log of this big number divided by the common log of the base. All right, so I'm just going to type that into my calculator. So I've got the common log of the big number divided by the common log of the base. And there's my answer. It's equal to 3. Okay, so, and now here's where some things get a little bit interesting. I probably don't need both sets of those parentheses. If I just type log 125, close the parentheses, divided by log 5, close the parentheses, that's good enough. But do notice that the log automatically makes a set of parentheses here, so I do have to close it. If I did not close those parentheses, if I just typed in this, that will give me a wrong answer. Okay, so I do have to be a little careful with that. Now, if you're using one of these types of calculators, of course, it also has the fraction tool that's built into it. So you can just type this right into a fraction, and that's fine. Okay, so that's an option. But the other thing is, if you're using this type of a calculator, just like you push alpha y equals to get the fractions, if you push alpha window, there's a logarithm feature built in where you can actually just type in your base. And it's nice and slick that way. Okay, but now that's only on certain calculators. If you have a normal, regular scientific calculator, like the one that's built into your computer, let me share that with you here real fast. Okay, so here I've got just a normal, regular scientific calculator that's built into my computer. It doesn't have anything except for the 2 logs. So here what I have to do is the log of 125. Whoops. Oh, I'm sorry. So on this particular calculator, you have to type in the number first, 125, and then log. It gives me this giant funky decimal, divided by 5 log. And now when I push equals, there's my answer. And I can see that what it's done is the 125, the log of 125 divided by the log of 5. Okay, so these are problems that we can do on our calculators, even if it's just a regular scientific calculator, nothing fancy like my graphing calculator. And of course, the other thing that we know, because we've seen it before, is there's this great website that's like, you know, Google for math geeks, Wolfram Alpha. And the same thing here, I can type in log of 125 divided by log of 5, and notice it gives me that answer of 3. And so life is good and wonderful. Okay, notice it even says, hey, look, we're assuming, okay, so life is good with that, everything is fine. We can do that with all kinds of different methods. All right, so I think that takes care of this video. Obviously, what you're going to see in the homework when we put all of this together is you're going to see equations like this one, an equation like this one, but the bases are not going to be limited to 10 or to e like they were in these examples. Okay, so you could definitely see something like, hey, let's solve a problem where it's 6 to the x equals 32. Okay, so then using one method or the other, I'm going to go through this very, very fast because the video is starting to get long at this point. Using one method or the other, we're going to switch it into a logarithm. So if I do the rewrite, I'm going to have log base 6. My answer becomes here. My old exponent becomes the answer. So if I do the rewrite, I get that. If I do it using an inverse, I'm going to take the log base 6 of the 2 sides because the bases have to match. Log base 6 of the 2 sides. These are going to cancel. I get x. Over here, I get log base 6 of 32. So no matter which way I do it, I get log base 6 of 32. And now what I have to do is type in my calculator using the change of base rule. So the log of 32 divided by the log of 6. And then that will give me my answer to this problem. So in this case, it's approximately 1.9. Okay, so these are some of the types of problems that you'll have to solve in the homework that's associated with this video. All right, that is it for this video. Thanks for watching. Have a good one.